Ephemeral bodies of water, also known as rock pools, are very small, often nothing more than a depression in an underlying rock. They are usually less than 2 meters deep and have less than 10 square meters of surface area. Also known as crazyness or namas, or simply potholes. These lentic water bodies can last for mere minutes or months. Rock pools are the only kind of lake in most non-glaciated desert areas, especially where there are no streams for oxbows or limestone for sinkholes. Rock pools form under different climates and conditions worldwide. These pools are some of the oldest and most persistent freshwater habitats in the world. Determining the morphology and hydrology of rock pool habitats is greatly dependent on the interactions between climate and geology. It is important to understand that the hydroperiods for such pools can range from mere minutes to months. Hydroperiods refer to the number of days the pool may be dry or the length of time that it has standing water in it. These pools are formed from weathering and erosion, resulting in similar geomorphology of the basin the world over. The only variation from pool to pool is surface area and depth. Rock pools have common shapes, ranging from pan to bucket shape. Their surface may be cylindrical or even ellipsoid in nature, with their dimensions varying. With erosion and weathering, overlapping of pools may occur, changing the common shape that is found.
Rock pools can be considered autonomous ecosystems on a small scale, or serve as representative models for larger systems. They are, however, incredibly complex in their own right, containing micro and macro invertebrates, larger vertebrates, and plant life. Many members of rock pool communities are capable of surviving long periods of drought and states of stasis. Many others experience greatly accelerated growth cycles in light of the instability of intermittent water bodies.
When it comes to vegetation, climate and geology is at work again. In pool areas that are rocky surfaces with drainage channels, they are likely to be inhabited by cyanobacteria, algae, and lichens. Some pool areas will see more herbaceous non-woody vegetation. Mat vegetation or wet flush vegetation can be differentiated based on their morphological or biological characteristics. A fundamental element of community ecology is the identification of factors and processes structuring communities. The process is divided into two, regional and local.
Over 400 species have been found within rock pool ecosystems. Most species that come to inhabit a rock pool arrive there by passive dispersal. Passive dispersal indicates that the organism needs some sort of vehicle to place them at the rock pool. The passive dispersal of these organisms commonly occur by air, water, or animal. This means that an organism will cast a net into the air and will be blown to a new location. This could also mean that the organism was washed away when the rock pool flooded, or somehow the microorganism was picked up by an animal and carried to a new location. Rock pools can contain many types of shrimp: crab shrimp, fairy shrimp, and tadpole shrimp that can be found in rock pools in Utah. Tadpole shrimp are living fossils, meaning they have not changed in appearance in over 200 million years. This makes them the oldest living creature known to man. One of the most fascinating creatures to be found in a rock pool or pothole environment is the tardigrade, sometimes referred to as the water bear or the moss piglet. This is a tiny creature who is only half of a millimeter in length. It is found all over the world, anywhere there is water. When the pothole is full of water, the tardigrade is happy swimming around. When the pothole starts to dry up, the water grade goes through an amazing change. The tardigrade begins to lose the moisture from its body, up to 99% of it. The tardigrade begins to secrete wax from its body. The wax creates a protective cyst around the body. Once they have completed the protective cyst, the tardigrade will slow its metabolism to 0.1% of its normal function. While they're in this hibernative state, the tardigrade will withstand some pretty extreme conditions. In labs, scientists have heated the hibernating tardigrade to 150 degrees Celsius and frozen them to minus 185 degrees, and nothing happens to them. They have even been exposed to 1,000 times the amount of radiation that can kill a human. They experience no tissue damage from within the cyst. They just wait for the rain. It only takes about 4 hours and the muddy tardigrade is off and swimming again.
Rock pools serve not only as animal habitat, but as a vital resource to mankind, particularly in arid and semi-arid regions. Namas, granite weathering holes located throughout Australia, at times provide the only available water for local people. This water is jealously guarded against both evaporation and animal use. Such rock pool formations are also integral to other populations around the world, from the American Southwest to Africa and Iceland. Ephemeral water bodies came under threat in Arizona in 2006 when the protected status of these systems was threatened by the Rapinas decision eliminating limits for point source pollution. The watershed under greatest threat is that which feeds the mostly ephemeral Gila River. Its tributaries and surrounding smaller lotic systems are also predominantly intermittent. The largest and fastest growing countries, Maricopa, Pima, and Pinal, are all located within the heart of this watershed. There is an increased threat to water resources with increased development and consumer demand. The greater the use, the greater the abuse.
Predictions of global warming and climate change are many and varied, ranging from 1 to 2 degrees temperature increases to doomsday scenarios as high as 6 to 7 degrees expected. Trends include wetter wet and drier dry areas. Studies of rock pools can serve to model larger ecosystems and aid in forecasting potential changes in global systems. Ecohydrology and interdisciplinary studies examine the relationship between water bodies and ecosystems, can help synthesize data from rock pool investigations into macromicroscopic perspectives. And remember, don't stick your finger in the wet pothole or your foot in the dry one. Just walk around them, and when you do, think a moment about the life that's waiting there at the bottom for the next big rain.